Generator fuel systems are complicated and hard to keep track of. There is heat and vibration and massive amounts of power, engine fluids, and exhaust fumes. All of this is accompanied by a tremendous amount of noise. The hazards of the area usually limit the amount of fuel that should be stored in the immediate vicinity. In order to continually transfer fuel into a high hazard area, it's important to have a design with a very high level of safety and reliability.
Generators require atmospheric reservoirs close to the unit and return flow without back pressure. For this reason, day tanks are used to provide a local source, or a generator sub-base tank is provided. The engine fuel pump draws fuel from the day tank and boosts the pressure. At full load, only about 1/3 of the fuel is consumed and 2/3 of the fuel flow is returned back to the day tank. Day tanks typically have capabilities to automatically refill from remote fuel supply tanks. Flow rates from remote storage should be about 2 times the maximum total engine consumption at full load. This is to provide a uniform flow to multiple generator day tanks. The recommended pressure at the day tank inlet valve should be 15 to 25 psi to provide steady flow. The return flow from the engine can be in excess of 200 degrees Fahrenheit. It is therefore imperative that fuel oil coolers be used to control day tank temperatures. Typically, these are slave fuel radiators that are mounted at the engine fan. Where remote radiators are used for the engines, fuel cooling radiators with integral fan units may be used. Where day tanks are remotely filled from bulk tanks, there is a risk of overfilling if refill equipment fails in some way. Overfilling of a day tank creates a dangerous fire and environmental hazard, and special precautions against overfill are required. A gravity overflow pipe running from the day tank to the main tank is the most common and safest form of protection and required by most standard codes. The gravity return flow pipe must be properly sized to be adequate for the design inlet flow to the day tank. Many codes require that the overflow pipe be a minimum of 1 pipe size larger than the fuel supply pipe. You should use a return flow pump system where gravity return flow is not possible. In addition to these pumps, it is common to use a redundant high-level inflow stop valve. This is normally an open solenoid valve that closes on day tank high level. Return flow pumps may be mounted directly on day tanks and controlled by the primary day tank controller. Often an independent high-level sensor is provided to operate the pump. An advantage of this arrangement is that the pump may also be used to lower the day tank level for commissioning and periodic testing of the refill function. Another method for providing the day tank protection is an overflow receiver and pump unit. The overflow receiver may be used to accept overflow from the group of individual day tanks. A header system is a response to fuel quantity limits for multi-generator applications. The header pipe is an 8 to 12 inch diameter pipe that runs the length of the generator installation. It acts as a common day tank for all generators with supply and return connections. The header pipe has a gravity overflow return to the fuel supply tank to maintain atmospheric pressure for the fuel supply. Pump controls operate to continually circulate fuel when generators are active.